Welcome to our Introduction to Algorithms course, and topic is Introduction to Data Structure. What is a data structure? Data structure is a specific way of arranging the data in a computer so that its usage is more effective and efficient. Data structures are a set of algorithms. They are useful to store data in a way that makes it extremely accessible and easy to manipulate. So here's the terms in data structure. First, data structure, data is elementary value, or we can also say that it's a collection of values. For example, employee name and employee ID are data about an employee. Group item. Data items having sub-data items are known as group items. For example, names, I can have the first name and surname of the employee. Record is the collection of various data items. For example, in the case of employee data, the record might consist of name, addresses, and destination, pay, scale, and working hours. Fourth, file. A file is a collection of multiple records, records of the same entity. For example, a collection of 500 employee records is a file. Entity. Entity is a class of certain objects. Each entity has various attributes. Each attribute represents a particular property of the entity. Field is an elementary unit of the information that represents the attribute of an entity. Here's the types of data structures. There are two types of data structures. Primitive data structure. Primitive data structure or data types is defined by a programming language and the type and size of the variables. Values are specific to the language. It doesn't have any additional methods. For example, int, float, double, long, and etc. These data types can hold a single value. Non-primitive data structure. These data structures are defined by the programs and not by the programming languages. These data structures can hold multiple values and make them easily accessible. So non-primitive data structures can further be classified into two types. First, a linear data structure. In the linear data structure, as the name suggests, data elements are arranged sequentially or linearly, where each element is in connection with its previous and next element. Since a single level of involved in a linear data structure, therefore the whole data structure is traversable through all the elements in a single run only. These data structures are easy to implement, for example, array, linked list, stack, or queue. And B, non-linear data structure. In non-linear data structure, the elements arrangement is not sequential or linear. Instead, they are arranged hierarchically. Hence, we cannot traverse through each element in one run. Non-linear data structures are a little bit more difficult to implement than linear data structures, but they use computer memory more efficiently compared to linear data structure, for example, graphs and trees. Data structures classification can also be done in the following two categories: static data structures and dynamic data structures. First, static data structure have a specific memory size, the allocation of which is done at the time of compilation. Therefore, these data structures have fixed memory size. An array is the best example of static data structure. Second, dynamic data structure. Dynamic data structures have flexible memory sizes since the memory allocation is done at the runtime. Hence, dynamic data structures can shrink or grow as and when required by delocating or allocating the memory respectively. For example, linked lists, stack, queue, graphs, and trees are dynamic data structures. Here's the tree of types of data structure. So here's two main types of data structure: primitive data structure, non-primitive data structure. Here's non-primitive data structure consists of two linear data structure and non-linear data structure. And non-linear data structure divided into four, like tree, graphs, tree hash table. And linear data structure is array, stack, queue, linked list, and etc. But in primitive data structure is only integer, float, character, boolean data. So also we will discuss basic operations on data structures. Some major and most common operations performed on a data structure are: first, search, finding an element in a data. Second, insert, inserting an element in a data structure. Delete, removing an element from a data structure. Update, manipulating an element in a data structure. Sort, arranging elements in a data structure in either ascending or descending order. Traversing, visiting every element of the data structure one by one, starting from the first element to perform some specific operation. And the last one is merging, combining two data structures, possibly of different sizes but of the same time or type. For example, both should be an array to form a third data structure. And here's the characteristic of data structures. Time complexity. Time complexity is the time taken for the execution of operations on the data structure. The expected time taken for execution should be minimum. Space complexity. Space complexity is the memory used for the execution of data structure operations. Memory used should also be as little as possible. Correctness. The interface of a data structure should be implemented correctly. And the next one is applications of data structures. Each type of data structures has different applications. For example, Arrays are useful in the arrangement of the leaderboard of games where we need to um, simply store the title and the score in ascending order. Web pages are easily accessible by using previous and next URL links, which is a good example of a linked list. Stacks are logic behind temporary storage in recursive operations. So we will learn about these operations in detail in future articles. And the shortest path algorithm is traveling salesman algorithms use graphs and their major data structure. So thank you.